Chapter 9, we're going to go ahead and look at gradient intercept form, which is what we did a few days ago, and this is just so you have it formally in your notes. We want to make sure that the gradient, which is also known as the slope of a line, and the intercept, we're talking about the y-intercept, all right? We have used two letters to talk about both of these. The slope, we've used the m to describe the gradient, and for the y-intercept, we've used the b. So every single time that you have a line in slope-intercept form or gradient-intercept form, your gradient is just the number in front of the x. It does not include the x. So there's your gradient. And then your y-intercept is the number that's added or subtracted to the term with the x. And that is including the sign in front of it, so it might be minus or plus b, but that is your y-intercept. It does not mean it is a y, it's the only y value in your equation because you have all these y values over here, but your b is specifically the y-intercept. So your y-intercept, remember, is when you actually cross the y-axis. So it would be where you are on the y-axis. So it'd be some point along this y-axis. So those two pieces of information are very helpful to us. So make sure you have that down. And let's look at an example about how this helps us graph. So if we're supposed to state the gradient and the y-intercept for these graphs, let's take a look at this first one. Again, I'm going to look at where the number is in front of the x, and that is my gradient, which we call m. And then the number that is added or subtracted to the term with the x, that is our y-intercept, and we call that your b. So we would say your gradient equals 2, and we would say your y-intercept equals 1. You could also write your y-intercept as 0, 1, because it's a point on the y-axis. So that's another option for how to write it. And let's take a look at the second example. Again, the number that's in front of the x is your m. And then the number that's added or subtracted is your b. Well, I don't have a number here that's added or subtracted. So if I don't have a number that's added or subtracted, then the only number that would be there would be a 0. So that means that my y-intercept must be 0. So that means my y-intercept should be going through should be the origin. So remember, the origin is where you pass through 0, 0. So my gradient is -3, and my y-intercept is 0. So if I had been asked to graph the example in section A, let's go ahead and get a graph up here. So with this graph, I'm going to go ahead and start. I always start with my y-intercept. So my y-intercept is at 0, 1. That's my starting point. And then from that point, I'm going to use the directions provided in my gradient. So my gradient, if it's just a 2, I can always put it over 1. So that means the 2 is telling me to go up 2, and the 1 is telling me to go right 1. So from that point, 0, 1 that I just plotted, I'm going to go up 2 and over 1. And I can keep doing this, up 2 over 1. And that will just give me more points on my line. And remember our discussion in class. If I can go up 2, right 1, that means I could also go down 2 and left 1, and I could hit more points on my line. All right? So then I can connect my dots, and I can make a beautiful line. So what we were looking at in class the other day was how I actually wound up making a line using your gradient and your y-intercept, and that's exactly how I would do it. In these next two examples, we're just looking at lines that are not already in the y equals mx plus b form. So if I were asked to find the gradient and the y-intercept, I wouldn't know yet because it's in the wrong form. So what I would have to do on my paper is write down this equation, and then I would try to use my skills to solve an equation for the y. So I'd want the y to be by itself. So if I want the y to be by itself, that means I'm going to subtract the 2x term, because I want to move this 2x term away from the y. And I know it's going to look a little funny, but what that's going to make your equation look like is I'm going to have a minus 2x on the right-hand side, and then I'm still going to have that plus 7. So all I've done is I've rearranged my equation, and if I move the 2x to the right, it has to go to the opposite sign, so it has to become negative. But that means now I can identify my m as negative 2, and I can identify my b as 7, and I could graph this line if I wanted to. Let's take a look at the second one because it's very similar. It has one extra step. For this one, I want to do the same thing. I want to move the terms away from the y. So I want to leave the y where it is. I want to move everything else away. So my first step is going to be subtract the 4x. If I do that, I'm going to be left with 2y because I haven't got rid of the 2 yet. But I will have negative 4x. I always want to write the x first. And then plus 10. However, I still want to get rid of this 2. And because the 2 is multiplied by the y, my next step is going to be to divide by 2. And when I divide by 2, that means I need to divide everything by 2. So 2 divided by 2 is just 1, so I just get the y. Negative 4 divided by 2 is negative 2, and I have to keep the x. 10 divided by 2 is 5. But now, since I went through that process of solving the equation for y, again, I can identify my gradient and my y-intercept. And if I can do that, I can graph it. All right? I will see you guys next time.